Hello, colleagues. Thank you for getting here. I'm here today, he says, for entertaining. Okay. Actually, I was going to talk about quite important things, important for me. I was going to talk about misbeliefs. Actually, I think that my presentation quite good fits into a line of like 3 presentations. 2 of them were made, like bright ones, were made by my colleagues. One on the one kind of misbeliefs, false flagging and false attribution, and another one was a bit deeper dive into the reasoning laying behind misbeliefs that my colleagues Yulia and Vladimir were researching. Today I decided just to pick up a few ones that I believe are among the most important. Actually, when I started working on the presentation, I picked up a bit different list of things, but at the very end I end up with a list of more simple things because I realized that they still are alive, and those simple things, they form a base level for the whole understanding and the whole concepts of industrial cybersecurity. Talking to people from industries, talking to journalists, for example, yesterday after our press conference, I realized that some of those basic, simple misbeliefs, those myths, are quite important still. So I decided to start with this one. Yesterday, after my presentation for journalists, I had a few interviews, including the ones with the representatives of different dedicated magazines that work for this or that particular industry in this or that region, and they said, no, our customers do not believe that their industrial control systems are exposed to threats coming from internet. And here we come to some other problem domain, which I would call misleading statements. Sometimes people say our systems are not connected to internet and therefore are not exposed to internet threats. Our experience of cybersecurity assessments, penetration testings, says us that 100% of our customers that we've done such research for have their people being able to get access from inside industrial network to internet. Of course, their industrial control systems were not directly exposed to internet. You cannot find them like via Shodan or any other engine like that. But having ability to get access to internet makes them vulnerable to and accessible to internet threats. Actually, I'll give you a few examples of probably the most weird ones I have ever seen of infrastructures being connected and interconnected with other infrastructures over internet. I mean, industrial control infrastructures, industrial control systems. Here's an example of a case when we were doing a cybersecurity assessment and penetration testing at one facility in Europe. Just the first day we started to do some first analysis, we have realized that from this particular facility, we have access not only to its corporate network, like office machines and financial systems, but also to industrial control systems, industrial control networks of many other facilities across the globe belonging to the same company, like few dozens. Some of them, which is even more weird, by that time were already owned by another owners, like concurring owners, because they, like the previous owner has sold them to someone else. How do you think they are connected? Of course, via internet. There are no any other ways to connect those types of infrastructures to each other. The other funny example, and quite a scaring one, like two digital substations. One day they got a connection link between them disappeared, like for some reason. This connection was not actually needed for their day-to-day work, but they were planning to use it like in some difficult circumstances, which fortunately have not happened by the time. So they tried to understand what was the reason for losing this connection, and with the help of the telecom provider who was providing them connection service, they have found out that the problem was a router. The most funny about this router that it was located in a publicly accessible area of a multiple like apartment, multi-resident building. So two critical infrastructures connecting through a router you can easily access. The other, I guess, in my opinion, this is the most weird one. We were doing penetration testing on one facility, and like doing those analysis of industrial network, have found out that from this industrial network we gain access to an internal financial like systems of a bank, like internal bank processing systems. It has appeared that the bigger holding that this enterprise belongs to used to have its own private bank, like doing some financial transactions for them, and then that at a moment they realized they don't need it anymore, and they have sold it to a bigger national wide bank. So at the moment we were doing this penetration testing, we have found out that a bigger internal infrastructure of like national scale bank is accessible, like bank internals, from industrial enterprise, not logically connected to this enterprise anymore, and vice versa, of course. You had possibility to get connection to industrial control systems from the banking network. I guess that keeping in mind that those industrial Internet of Things, Industry 4.0, and the ability to grow for industrial businesses relying on connectivity will make in the future people not be showing off, saying my industrial control systems are not connected to internet or having no access to internet, because in a few years, maybe 5 or 10 years, God knows what, how many, the efficiency of industrial enterprise would be highly dependent on whether it's connected or not connected. Of course, it comes the price of some cyber threats. Here's the statistics of attacks that we monitor and detect and prevent on daily basis on hundreds of thousands of industrial machines all over the globe, running our solution and sending anonymized statistics to us. Those numbers are relative, so we get the total number of machines sending statistics and calculate how many of them have experienced cyber attack during this particular period. So 40% means that 40% of all the machines sending statistics in this or that industry currently totally in the globe have been attacked at least once during the half a year. And we can notice that not only the number of attacks or density of attacks, but also the diversity of malware attacking those industrial systems increases on yearly basis. If you look at the infection sources, the ways the malware gets onto industrial control systems, you would find out that two, the more obvious ones, internet browsers and corporate email are among the major infection sources. The second misbelief is not maybe that straightforward. I continue to hear this from guys within the industries. They say there's no practical reasons to attack us because there's no simple way to monetize on the attacks. They say, since criminals are not interested in attacking us, then we either are not attacked at all, like no one targeted us, or we might be targeted by like a very sophisticated, very capable threat actor that we cannot just stand. So there's no reason to try and spend so many resources to protect ourselves because we will fail. Actually, analyzing a few recent attack campaigns, we have found out that a bad tendency exists, and we just try to analyze it. Criminals find out that industrial enterprises are a very interesting target for financial attacks because of various factors like number of financial transactions, the sums, the delayed transactions, and absence of regulation, the same level as in financial sphere, and many other aspects. They have found out that industrial companies are very interesting targets. So we've seen examples of widespread attacks targeting hundreds of industrial enterprises and only industrial enterprises for financial benefits. Also, you should notice that both like traditionally not sophisticated threat actors, not capable threat actors like Nigerian fishers, the more sophisticated one, Russian criminals, and the ones who is treated to be the most sophisticated ones, those ones are treated as a national state actor. They share the same technology, the same tactics, and even sometimes they target the same companies. Which means that you can use the same measures, the same tools, the same processes to protect yourself from all of those attack vectors. All is doable. Of course, everyone agrees that people are one of the weakest links for inside industrial control systems and industrial enterprises. But sometimes we hear that, okay, to protect our people from random attacks, we just need to teach them not to do stupid things. Which I believe is true, but it's a kind of half a true. That's an evidence saying that probably this is true. This is our monthly statistics showing that in summer times we have less attacks on industrial control systems than average, probably because there's less people working on site. We decided to pick up one example that is really interested to look at, to do the analysis, where like teaching people and make them not do stupid things is sufficient or not. We have picked up Japan. Talking to Japanese companies, talking to Japanese like governmental bodies, we have realized that on normal like industrial enterprise in Japan, people would behave quite safely. They would not do stupid things like clicking malicious links because they just do not have malicious links to click. They would not be launching some unnecessary software. They just do the things they were taught to do because of their job responsibilities. They don't use too much of like protecting systems, like sophisticated next-generation firewalls, anti-targeted attacks, and those kinds of things. They sometimes use endpoint protecting systems that we are getting statistics from. So if you look at the graph, you would find out that they are performing quite well, being compared with the countries in the region. But if you look at the top performance, the countries that are protected better, like Denmark or Ireland, Switzerland, United Kingdom, Israel, USA, Belgium, Germany, you would find out that probably their approach is quite efficient, but they could do better if they decided to use more tools to protect them. Then we decided to investigate whether there is any correlation between tool usage and resources available and spent for industrial protection and the density of attacks on industrial control systems, or the number of attacks that somehow manage to bypass all the barriers and perimeters and to attack machines inside industrial networks. And we have come up with this correlation graph. The vertical axis shows the GDP rank of the country, while the horizontal one shows the number of attacks that we detect. And we see quite a good correlation, really very, very good, like showing that countries who spend much money, who have much money available to protect their industrial enterprise because they have more money per person, per enterprise generally, they perform better in terms of cybersecurity, in terms of like securing their industrial assets from cyber attacks than the ones who have less money. We can also see that there are some deviations, like people or countries that might spend their resources better, and the ones who perform really good. I believe this one is the most dangerous one because it leads to a wrong way selection. I mean, the wrong way to protect industrial control systems. Some people believe that safety measures are enough to secure their industrial infrastructures, and they are trying to make security a subdomain of safety. Making things easier, like making risks measurable and predictable, making them quite easy to mitigate, which I believe would not work with cyber attacks that, in my understanding, are much closer to a space of world warfare than just normal traditional risk management. Here are the few examples showing that probably I'm right. All of you have heard many times about this attack vectors on safety systems utilized by Triton. So we see that safety systems are vulnerable, and not only having binary vulnerabilities, but having architectural vulnerabilities, not being able to cope with cyber threats. So those cyber threats could lead to those systems not working. In this particular accident, it was not probably that dangerous because it put the whole system into safety state. But I believe that there are other attack vectors that would allow a malicious actor to use safety systems to get control over the systems that those safety systems were designed to protect. Because the capabilities of safety systems are quite diverse. They need quite many control measures to put a system into a safety state. That's not just switch everything off. Oh, okay, it's switch everything off, but to switch it properly, you need to have almost all the controls you need to control the environment. Here are like a few samples of attacks that utilize such attack vector. That one we have done a couple of years ago on the same conference in Russian city of Kazan. Here is an example of a version of smart grid, a microgrid, and attacks utilizing vulnerabilities of microgrid safety system they led to physical subsequences. The same attack vector, probably not that devastating, was utilized by attackers staying behind attacks on Ukrainian power plants in 2015, and almost the same in 2016. The last but not the least, I keep hearing from people within the industry saying that, okay, from times of Stuxnet, ICS vendors have a long way to make their systems more secure. And sometimes we started to hear the word sequence, the phrase "secure by design." This probably would make many security people smile, but many believe that there is a possibility, a theoretical possibility to create something absolutely secure by design. Those are our findings of the recent couple of years, a bit less than a couple of years, like 160 0 days, and the most recent versions of industrial control systems system products spread all over the globe, like the top ones, the ones coming out of production of the top vendors. And we see that half of them are fixed. Are they secure? A little bit more secure than they were before, but I think not because they are secure by design. I would like to draw your attention to this red bar. Those are components and technologies that are widely used across the industries and being adopted sometimes by hundreds or even thousands of vendors in their products, therefore affecting tens of thousands or hundreds of thousands or millions of installations, I suppose. One example of that, this is a little bit of advertisement of their new product of one of the biggest and well-respected vendor. While advertising their product based on this technology, one of the key slogans was secure by design methodologies that were used while developing this product and this technology that is being utilized by the product. At some point, we were involved into the development of this technology. So we became a part of OPC Foundation, and we were invited to OPC Foundation Security Work Group. So we started to investigate the cybersecurity state of the product and technologies, and have found 17 0 days in this product. By the way, this is one of the technologies that quite many like modern trends and modern ideas rely on, like industrial Internet of Things, smart cities, some other kind of things. Currently, there are almost 470 vendors that use this technology inside their products. And that's not only the one and only finding of such. We have done a few and are willing to publish more reports on this because our investigation and our research is almost done on some more technologies. So welcome on our side, and yes, we have quite many things yet to do to make the world secure. Thank you.